In this section, we are going to be talking about ratios and proportions. A ratio is a quotient of two numbers, or the quotient of two quantities that have the same units. We can write a ratio as a fraction, or we can write it with a colon. So if we said 1 to 2, this is how we would write it, 1 to 2. But we could also write it as a fraction, 1 over 2. These are the same thing. So let's look at problem 33. Find the ratio of 45 minutes to 2 hours. Simplify the fraction if possible. Now remember, in order for us to do this properly, they have to have the same units. So how many minutes are in 2 hours? There are 60 minutes in an hour, so there are 120 minutes in 2 hours. So our ratio is going to be 45 to 120. Or if we want to write it as a fraction, it'd be 45 over 120. How can we reduce this? Well, we know that both 45 and 120 are divisible by 5, so let's try to reduce that. We get 9 to, what's 120 divided by 5? 24. Both 9 and 24 are divisible by 3, and we get 3 to 8. Or we can reduce our fraction to 3/8. Both of these are considered correct answers. A rate is a quotient of two quantities with different units. You must include the units. So let's look at problem 34. A car travels 105 miles in 2 hours. Write this rate as a fraction. So we have 105 miles over 2 hours. We cannot reduce this any further, so this is our final answer. A unit rate has a denominator of 1. If necessary, divide the numerator by the denominator and express the rate as a mixed number or decimal. So a car travels 105 miles in 2 hours. Write this as a unit rate. So our regular rate was 105 miles over 2 hours. So to find our unit rate, we have to take 105 and divide it by 2, and we get 52.5 miles per hour. Remember, back in our word problem days, the slash means per. Per always means division. Let's look at unit price. A unit price is a rate with price in the numerator and the denominator equal to 1. The unit price tells us the cost of one unit or one item. So an 18-ounce box of cereal costs $3.59. Find the unit price. So we have price in the numerator. So we're going to look for price per ounce here. Over 18 ounces. So how much is that per ounce? So that's about 20 cents per ounce. We're talking dollars, so we can round to the nearest cents. How about a 12-ounce box of cereal that costs $2.99? Let's try that. we get about 25 cents per ounce. Which box has the lower unit price? So we look at our unit prices, compare, and it looks like the 18-ounce box of cereal has the lower unit price. Now let's take a look at proportions. Proportions say that two ratios or rates are equal. So in problem 37, we're going to determine whether each proportion is true or false by simplifying the fraction. So how can we simplify 6/8? Well, 6 and 8 are both divisible by 2, so we'll divide both the top and bottom by 2, and we get 3/4. How about 21 and 28? 21 and 28 are both divisible by 7, so we get 3/4. So this one is true. How about number 2? Both 10 and 15 are divisible by 5, so we get 2/3. 16 and 20 are both divisible by 4, so we get 4/5. These are not equal, so this proportion is false. Another way we can determine whether a proportion is true or false is with cross-multiplying. So cross-multiplying is when we take the numerator on one side, multiply it by the denominator on the other side. Take the denominator from the first side, multiply it by the numerator on the other side. So let's try that. 6 times 28. See if it's equal to 8 times 21. So let's do that in our calculator. 168. About 8 times 21. 168. So we used cross multiplication to determine that this proportion is true as well. How about number 2? 10 times 20 is 200 equals, what's 15 times 16? 240. These are not equal, so this is false. We have problem 39 for you to work on your own, so go ahead, pause the video, and see if these proportions are true or false by cross-multiplying. Welcome back. Let's see if we can find missing numbers to make proportions true. So here are some steps to solve a proportion. We're going to start by cross-multiplying, then we'll isolate the variable, and then we will check our answer. So let's do this. Cross-multiplying, we get 8 times 15 equals 10x. What is 8 times 15? 120. Divide both sides by 10, we get 12 equals x. Let's see if this is true. 8 over 10 equals 12 over 15. I'm going to reduce my fractions to see if this is true. Both 8 and 10 are divisible by 2. We get 4/5. 12 and 15 are divisible by 3, so we get 4/5. So this is true. That is indeed our correct answer. Now, if you preferred, you could have simplified this fraction before cross-multiplying. That is completely okay. Would have ended up with much smaller numbers, and it may have been easier to figure out. Let's try this next one. 3/2 equals 7.5 over n. So let's cross multiply. 3 times n equals 2 times 7.5. So 3n equals 15. Divide both sides by 3, we get n equals 5. So let's check our answer. 3 halves equals 7.5 over 5. Now, it's not as easy to reduce fractions when they involve decimals, so this time I'm going to cross multiply. So I get 3 times 5 is 15. 2 times 7.5 is 15. This is correct, so this is our correct answer. Last one before you work on some yourself. Let's start by reducing this fraction. This fraction's kind of a nightmare. So 18 is divisible by 6, 24 is divisible by 6. We get 3/4 on this side. So at this point, do we need to cross multiply? We have 3 equals 3 on top, k equals 4 on the bottom, so k has to equal 4, right? We can cross multiply to verify. 4 times 3 is 12. 3 times k, divide both sides by 3, and yes, indeed, we get 4 equals k. So sometimes when you reduce the fraction, it'll just give you the answer straight out. So go ahead, pause the video, use whatever strategy works best for you to solve these proportions. Welcome back, and now we get to deal with your favorite thing in the world, word problems. Hooray! All right, problems that involve rates, ratios, scale models, etc. can be solved with proportions. When solving a real-world word problem using a proportion, be consistent with the units. So we need to make sure that if we're talking hours, we're not talking minutes on the other side. If we're talking kilometers, we're not talking miles on the other side. All of the units have to be the same. Tanisha drove her car 320 miles and used 12.5 gallons of gas. At this rate, how far could she drive using 10 gallons of gas? So what we're going to do is we're going to put 320 miles on top and 12.5 gallons on the bottom. She was able to drive 320 miles per 12.5 gallons. So how far could she drive with 10 gallons? We don't know the distance, so it's X miles over 10 gallons. So you want to make sure on both sides miles are on top, gallons are on the bottom. You could have written it 12.5 gallons per 320 miles. That would have been perfectly fine too, but you would had to have made sure that you had 10 gallons on top and X on the bottom. So long story short, it doesn't matter which unit is on the top, which is on the bottom, as long as they match on the top and they match on the bottom. You will get the correct answer either way. Let's cross multiply to figure this out. So 320 times 10 equals 12.5x. 3200 equals 12.5x. Divide both sides by 12.5. And we get 256 miles. That is our final answer. Another way to check these answers is you can just do the division in your calculator and make sure both sides are equal. So let's try that. 320 divided by 12.5 gives us 25.6. So our unit value of this is 25.6 miles per gallon. Let's see if the other side matches. 256 divided by 10 gives us 25.6 miles per gallon. So this checks out, and this is indeed our correct answer. At this point, you can pause, look at these last few problems, Say hello to the late great Alex Trebek, and I will meet you to talk about variations in the next video.